All right, turn in your textbooks to page 133. Page 133. And you had just two equations on this page that you were supposed to convert to slope-intercept form and graph. Then the rest of the homework was back on page 130 in the review section. So let's start by taking a look at the graph, number 4 and number 8. And of course you have the 1 through 4, 8, and 9 on. There we go, good. You didn't have graph paper.
So I made one.
Okay, where's the rest of the homework? Previous page perhaps? Yeah, that looks like it right there. Good. Good. Alright, so I'm going to do what Brecken did, and I'm going to be lazy and not pull down the graph grid because I'm too lazy for that. And so on number 4 from the homework, you're given the equation 3x negative 2y is equal to 6. Now I'll be honest, I probably use the intercept method here if I've got the choice. But the instructions say to convert it to slope-intercept form. So, Maddie, what do we need to do?
You need to write negative 2y equals and then you change on the sides. And you divide by 2. And you get y equals 3 2.
There we go. So clearly now, class, we can see that the y-intercept is negative 3, and the slope is 3 over 2. And we remember slope always is what over what, class? Rise over run, right? It's never run over rise. It's always rise over run. So, on my homemade Cartesian plane, we'll start down here at negative 3, and then from there, Maddie, we will rise and run forward, which, by the way, if we'd done the intercept method, it would be the exact same 2 points, and we'll connect the dots to get a line that looks like that. And did we get that line for number 4? All right, let's take a look at number 8 now. And we had an x negative 4y equals 10. I'm not too crazy about the intercept method on this one, only because I can already see my x-intercept would be a 10, and I don't want to plot a 10, especially now with what I've got going on here. So, Brecken, what do we need to do? Okay, unlike last time where Maddie went ahead and just dealt with the negative as is, we could eliminate the negative by pulling a double swap here, giving us what?
4y equals x.
Good, x minus 10 equals 4y, but I like that Brecken went and just said 4y equals the x negative 10. From here we would need to divide everything by 4. And when we do, we end up with y is equal to 5 halves. Now, for graphing purposes, we've got to think, well, what does negative 5 halves really mean, Noah? A half. Yes. Right, negative 2 1/2. So this, my y-intercept for this graph is only going to be half a box higher than my y-intercept on the last graph. However, this time, my slope is going to be quite a bit different. This time, Brecken, from this halfway mark, we're going to rise 1, so we're going to go here, and then we're going to run positive 4. So from here, staying along that line, 1, 2, 3, 4, and we should get a line that looks something like that. And did we get a line like that for this graph? All right, questions? All right, be careful with your fractions, and again, it's a little unsightly, but it's converted into a mixed number so you get the correct location there. Questions on 4 and 8, slope-intercept form. All right, flip back if you would to page 130. Page 130. And the numbers 1 through 4, just some review. That's been a long time since we've really looked at this. Simplifying expressions, removing parentheses, combining like terms, and on number 1, there's actually 2 sets of parentheses. One's a parenthesis and one's the bracket. Which one do we need to get rid of first, Maddie? Because they're the inside one, remember, so we work inside out. Now to get rid of that inside set of parentheses, Maddie, we have to Good. She didn't just say distribute, nor did she say distribute a 3, but distribute a negative 3, and she's exactly right. So I'm going to leave the 2x, I'm going to leave the negative, I'm going to leave the bracket, I'm going to leave the x, but then I'm going to distribute the negative 3, Maddie, to get... Good, negative 3x, negative 12. Now the parentheses are gone. Now I'm ready to take care of the brackets, Noah. How do I get rid of the brackets?
You change all the signs.
Right, change all the signs. And it's important to remember that the x has an understood positive in front of it right now. So when I change all the signs, what do I write?
2x, negative x, positive 3x, positive 12.
Now the positive 12 has no friends. But the 2x, 3x, and 1x, or negative 1x, can all combine to give us
4.
And then we'll keep the positive 12. And there's our answer, 4x, positive 12. Number 2 is very similar, and then we need to get rid of the parentheses first by just changing all the signs. Once we've done that, just drop the brackets off. They're preceded by a positive anyway. What did you get for your answer on number 2, Brecken?
I did it wrong over here.
Ah, okay, then let's go ahead and work it together now, starting by removing the parentheses. Now removing the brackets. Let's combine the y cubes and combine the numbers. And there we go. And there's our answer. How many had that answer for number 2? Ooh, question Matt. All right, number 3. Just do what to get rid of the parentheses here, Noah?
Drop them.
On number 3?
Distribute.
The
5.
It's not a 5.
Negative 5.
Negative 5. We got to watch for that. What should we get when we distribute? Obviously, we'll start with the negative 2ab, and then we'll have
Negative 5ab. Negative 10.
good. And then we combine like terms. We end up with an answer of.
Negative 7ab. Negative 2.
There we go. How many had that answer for number 3? Questions?
I just brought negative 10. I made it a positive 10 instead of negative.
And it was a negative. It was a positive 2, so the negative 5 had to make it become the negative 10. All right, number 4. Tell me what to write down. Really, just the one first initial step here, Brecken.
5x, negative 2x, negative 3y.
Negative 3y, you said? Look in your textbook.
For number
For number 4.
it'd be 5x, negative 2x. Would be positive.
It would be positive 3x. So we have a negative in front of parentheses, so that negative changes to a positive.
Negative 2z, negative 7y, positive 2.
Now, Brecken, you changed those 3 signs, but you didn't change those ones. What's up with that? Yeah, they weren't in the parentheses, so obviously we don't change those. When we combine the x's, we combine the y's, we combine the z's. Final answer, Maddie? Good. 3x, negative 4y, negative z. Did we have that for number 4? Question? All right, questions on stuff we've been doing since the second week of school? Third week of school? It's been a while though, right? So good review for us on removing parentheses. Number 9, we're going to jump down there. More slope-intercept form stuff. Read the directions that are in bold, Noah.
Find the equations. Oh, wait.
For number 9, right above that, you were right. Read it.
Find the equations of lines that are parallel and perpendicular to the given line and pass through the point 2 and 5.
All right, so the line for number 9 was what? It's in your book. Just read the equation.
3x negative 2y equals 7.
All right, so this is my given line, right? I really don't care what it looks like, but that's my given line. And I'm supposed to find the equation of a parallel and of a perpendicular. And both of them are going through what point?
2, 5.
You said 2, 5?
Yes.
Okay, so we're going to find the equation of a parallel line through 2, 5 and a perpendicular line through 2, 5. Now, when we see parallel, class, we should think 2 words.
Same slope.
Same slope. When we see perpendicular, we should think 3 words. Negative reciprocal slope. And the word that you ended with both times was the word slope. So you know what I need to know?
Slope.
the slope of the given line. So in order to know the slope, the best way to do it is to put the equation into class slope-intercept form. What does the equation look like in slope-intercept form? Brecken?
Y equals 3/2 x -7.
-7/2? Now, the good news for Brecken is, even if he botches this, it doesn't really matter, because the only part of the equation I cared about all along was, what is the slope? Because if that's the slope of the given line, then therefore the slope of my parallel line is going to be what class? 3/2. And the slope of my perpendicular line is going to be what class? -2/3. Given a point, given a slope, we know how to find the equation of a line. Start, Maddie, by writing out. And then we're going to plug in for everything except the b. What do I plug in for the y, Maddie? The 5, which is my y value. Of course, in for the m, 3/2, and then for the x, 2. So 5 equals 3/2 times 2 over 1 plus b. Conveniently, the 2's are going to cancel, leaving me with just which I'm going to do the other side as a, to get b is equal to 2. Well, there's m, there's b. What is the equation of my parallel, Maddie? There we go. How many have this as the equation of your parallel? All right, good question, Noah. All right, now for the perpendicular. Once again, though, Noah, we're going to start by writing out. And once again, our y value is
5.
Our m this time is,
-2/3.
our x is once again
2.
over 1. And unfortunately this time, no, the 2's don't cancel. So I just multiply, and what do I get right here?
-4/3.
Yeah, 5 equals -4/3 plus b. Now I've got a couple options here, Noah. Option number 1 would be
Move it over.
as a,
Whole fraction.
right, move the whole fraction over to make it positive 4/3, right? But this 5 needs to be written as some number of thirds. Right now it's technically 5 over 1. I would need to multiply top and bottom by
3.
to get
15.
15 thirds. So I could add 15 thirds and 4 thirds to get a b value of 19 thirds. There's my m, there's my b. What's the equation of the perpendicular, Noah?
Y equals -2/3 x plus 19/2.
There we go. Now that's one way of doing it. The other way, of course, class, once you get here, would be to just get rid of the fraction by multiplying everything by the LCD. You do get the same answer, though. How many have that answer for your perpendicular? All right, I know it makes sense now. Questions at all on parallel perpendicular lines? All right. Now let's take a look at number 8. And we began looking at investment word problems yesterday. And I said that with investment word problems, they're based on the simple interest formula. What is the simple interest formula, Brecken? Good, I equals PRT, where P stands for the, I think you said it, what'd you say? Principal. What does principal mean? That's the $500 you owe Noah. That's how much money you borrow. Or, from Noah's perspective, that's how much money he loans out, right? The R, of course, just stands for rate. But the rate will always be given class as a percent. I can't work with percents. I've got to change it to a decimal by moving it how many places, Brecken? 2 places, right? And then the T stands for time, which most of the time ends up being what in our word problems? A year. And since time is supposed to be in years, 1 year is just 1, and so I don't care about 1 because anything that's 1 is itself. So oftentimes the time column can drop out, and then once we multiply the P, the R, and if we have it, the T, that'll leave us with the I, and we can go from there. So looking at number 8, go ahead and read that problem for us if you would, sir.
Two investments provide an annual income of $1,818. There is 3,000 more invested at 10% than at 12%. How much was invested at each rate?
All right, so somebody with money just every year has this money loaned out, and every year makes $1,818, something like that. Okay, so we've got two different investments, right? And the two different investments are given to us in terms of their interest rates. One rate is,
10%.
and the other is,
12%.
so we got a 10% investment, whatever it is, and we've got a 12% investment, whatever that is, right? We set up our two unknowns, and then we make our columns. P times R. Do we need a T column, class? No, once again, we can leave that off. Equals I. Now, the rate's clearly spelled out, but I'm not going to write 10%, 12% bracket. I'm going to write, there we go. Now, the principle is different on the homework than it was in class yesterday. Because in class, remember, I always gave you, or the book had given us, the total investment. So we picked one of them, class, to be, and the other as total minus X. Not the case here. It specifically tells me what about the amount of investment. It tells me what about the principal, Maddie? 3,000 more at 10% than at 12%. So which one has to be X, class? The 12%, because that's what it comes back to. 3,000 more at 10% than at 12%. This one has to be X, and it's not going to be total minus X, but rather, Maddie, I should represent this principal because there were 3,000 more dollars invested there. Did we get the initial setup correct here? Did we read it correctly? Nobody. Finish it at your seats. Does it make sense now? All right, for sake of time, I'm going to look up this way. Hopefully, you simply wrote your interest as 0.10 times x plus 3,000 and 0.12 times x, correct? And hopefully you added these two amounts of interest to get the total interest income. Hopefully you then recognize that in this term I need to move the decimal twice here, not inside, just outside, twice here, and twice here to get 10 times x plus 3,000 plus 12x equals 181,800. Everyone good so far? Question, Noah?
No, I distributed.
You distributed the 0.10 first. Okay, and that would have still gotten you, though, once you move the decimal 2 places everywhere, because there were no parentheses now, 10x plus 30,000 plus 12x equals 181,800. Still got to this point? Okay, because had you distributed 0.10x plus 300, so what you should have gotten, you multiplied by 0.1, plus 0.12x equals 1818. When you move it twice, that's what you should have gotten. Here, 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 here. From there, combine, kick out the 30,000 to get 180 or 151,800 when you subtract it away. And then comes the fun part, right? The division. And we divide it out. End up getting $6,900. That's X. That's how much was invested at 12%. 3,000 more at 10% means $9,900. So this person who was investing apparently invested $16,800. Must be nice to have that kind of money. Questions on that? Questions on that? All right. At your seats, I want you to turn back to page 89 now. Page 89. And let's take a look at word problem number 10. And we're going to look at it from the negative perspective here, right? We've been looking at making money, loaning out money, making money, collecting interest. The downside is if you're the one who has to borrow the money and pay the interest. Number 10. Noah, go ahead and read it for us.
John Baxley borrowed $25,000 for 1 year. He borrowed some at 13% interest and the rest at 15% interest. At the end of the year, he owed $3,600 in interest. How much did he borrow at each rate?
All right, so I will throw this out there. I've got several credit cards, and I was actually just looking at this the other day for my own reasons. It had nothing to do with math class. I was trying to figure out which is my lowest interest credit card, and my lowest interest credit card is 13%. Well, 12.99%, but 13% is my lowest credit card. Most of my credit cards are 15%. Now, I've got very good credit, excellent credit, in fact. So some people, same credit card I've got, their credit card company's charging 21% interest or 26% interest. Okay, so it depends on the credit you've got, but John Baxley probably has excellent credit. I also know from my experience, $25,000 on 2 credit cards probably maxes out both cards, okay? Probably has borrowed as much as he can, and that's a whole lot of interest to pay back at the end of the year. All right, so this is not a good situation that John Baxley's got himself into, but let me put it this way. Suppose, let's say his daughter has cancer and needs treatments. I'd be maxing out the credit cards if that's what I had to do. I mean, she's got to have the treatments. She's my daughter. I love her. I'm not just going to let her, die if there's a chance I could do something. I'll worry about how I'm going to pay it off later, but she's got to have the treatments, right? So maybe that was the case. That said, I think there's probably a better avenue than putting it on a credit card, but we'll just go with that, all right? So at your seats, I want you to set up the chart. Set up the chart with all the numbers. I'm assuming credit cards here, so there's no reason to take out a personal loan at that interest rate, so surely it's credit cards. Check your box. Everything good to go? If it is, keep working. How many are good to go? Everything's set up exactly right. Okay, you didn't even have to include the T column. I just wanted to go ahead and show it there. All right, keep working. For sake of time, let's go ahead and pause where you're at. The math here shouldn't have been too bad. As we're working here, take the decimal, knock it off. I assume we got to this point, correct? Everyone was able to make it successfully to this point. Set up the equation, remove the parentheses. At this point, distribute. Now, this is probably the hardest step here, right? Just multiplying 13 by 25,000. Should have gotten 325,000. Be careful. And then the combining, really not bad, 2x. That's a nice, easy number to divide by. Bring the 325,000 over with the 360,000 as a negative. 35,000, our answer there. And then for x in it with 17,500. Did you get that answer? How many made it that far and got the x? Okay, no, you were able to get there. Maddie, what was the problem? Didn't get 325,000. Okay, so multiplication error messed it up from there. Once we get the x, of course, we'll just subtract the 17,500 from the 25,000, $7,500 on the 13% card. So probably should have put more on the one. But anyway, questions on this? All right, practice with another one of these for homework this evening. For now, I want to transition back to what we began looking at yesterday, talking about inequalities. Again, equalities or equations are what we've been looking at all year long, things that are equal to each other. Beginning now to look at things that are not equal to each other. So obviously here, this symbol class just means equals. This means not equal, is not equal to, cannot equal, does not equal. How would we read this symbol? Greater than, right? And then here would then be less than. Greater than or equal to, less than or equal to. So is 5 greater than 5, class? No. Is 5 greater than or equal to 5? Yes. Okay, so again, there's the difference. The or equal to allows. Now 6 is greater than 5, 7 is greater than 5, 8 is greater than 5. 6 is greater than or equal to 5. 7 is greater than or equal to 5. 8 is greater than or equal to 5. The difference is now 5 can also be included as one of the possible values. And so on the number line, if I wanted to show greater than 5, obviously it would be all these points up here. And how would I show that? Well, but 5 isn't greater than 5. How would I show that, Maddie? a little circle around the 5. So not that one, but after that everything. But if I have the or equal to 5, the difference there, then no, I would put a dot filled in to include, yes, the 5 is one of these values. It's my starting point, and then everything after. Do you remember talking through this yesterday? For homework last night, you also had page 129, numbers 8, 11, and 13. Go ahead and turn there, page 129. And let's take a look at numbers 8, 11, and 13. For number 8, you were supposed to graph x is greater than or equal to 6 and x is less than 4 on the same number line. So, of course, for our number lines, we always have the arrowheads at the end going to infinity and negative infinity. Basically, it's an x-axis. We have our origin, 0. But I also need to mark 2 specific values on the number line, Brecken. 4 and 6, since those are 2 values in question here. As far as the 4 is concerned, class, what marking should I put on the 4? An open circle. There's no or equal to line. And then I should shade my arrow all the way to the left, going smaller, because x is less than 4. And then as far as the 6 is concerned, class, I should put a dot on the 6, since I do have an or equal to, and of course I should shade everything to the right side. And there would be our answer there. Do we get this graph for number 8? All right, then for number 11, you were given a graph and you were asked what inequality describes that graph. Brecken, what did you have for your answer? Great job. X is greater than 3. Not or equal to, because we have the open circle, and certainly greater than, not less than. Again, that should be written. X is greater than 3. X representing any and all points that could possibly be bigger than 3. So the mouth opens to the X because these values are greater than 3. Then for number 13, how would we write that, Maddie? Good. Less than or equal to -1. Again, the mouth will open to the -1 since that's the greatest value. We do need that or equal to, as indicated by the solid dot. Did we get all 3 of these correct? We're good to go on the inequalities. Any questions at all? All right. I want you to consider something for a moment then. Suppose I gave you this statement. 2x plus 3 is greater than or equal to 7. Now, this isn't an equation, right? It's an inequality, okay, because it doesn't have an equal sign. And here's my question. Can x equal -2? Well, let's think this through. You plug a -2 in right here, class. What's 2 times -2? -4 plus 3? -4 plus 3, class? -1. Is -1 greater than or equal to 7? No, so x cannot equal -2. What about 0? Could x be 0? Think it through for a moment in your head. Maddie's shaking her head. No, because I'm plugging the 0, I get 3 bigger now. 3's not bigger. What about 2? Could x equal a 2? Getting nods across the board, right? Because 2 would give me a value of exactly 7, which is just barely, right? It's just equal to 7. What about a 5? Could I have a 5 in there? Getting nods. All right, yeah, of course. In fact, anything bigger than 2, I'd be good, wouldn't I? As long as I had at least 2. How about this one? Do this one at your seats. Suppose I have a 3x -6 is less than 12. 3x -6 is less than 12. I want to know if x could equal 0, 4, 6, or 7. Maddie's got her verdicts in. Brecken's good to go. All right. What's the verdict on 0, class? Yay or nay?
No.
Yay. You plug in a 0 here. 3 times 0 is 0. -6 is -6. Is -6 smaller than 12? Yeah, 0 should be good to go. What about a 4? What's the verdict on 4? C. Yeah. Okay, you plug in a 4. 3 times 4 is 12 minus 6 is 6. Is 6 less than 12? C. All right, what about a 6? Yet. You plug in a 6 here. This 3 times 6 is 18 minus 6 is 12. Is 12 less than 12? No, less than or equal to would have been yes, but it's not equal to, so no. And then the verdict on 7 would also be no, right? It's 21 minus 6, 15 is not less than 12. Did we get 0, 4, yes, 6, 7? No. Questions, Noah?
I did it backwards.
Did it backwards. So again, the important thing to recognize, this means less than, so the 12 has to be the big thing, because the mouth's open to the 12. Whatever you get over here has to be the little thing that's getting ignored by the alligator. Okay, sometimes it pays to be smaller, like... I would pick on her, but she's busy watching a video back there. Let's say, so if Noah and Brecken are in the same river and the alligator's coming, actually it just pays to be fast, right? It doesn't matter how little you are, it just pays to be a fast swimmer then, because the slower swimmer gets eaten, right? Like, I don't have to be able to outrun a lion, I just have to be able to outrun Noah. And what was the old joke? There was a lady and her husband walking through the woods, and a bear came out of the woods and began to attack them. And with just a single shot from a .22 caliber revolver, she was able to save her life. She shot her husband in the kneecap. Okay, I'm not advocating that, okay? He should have been nicer to her, okay? Maybe he shouldn't have taken her out in the woods where there were bears, okay? Be smart. But anyway, Maddie's like, so I really do only need a 22. Here I was saving up for a 45. Nope, 22 will take out a man's kneecap just fine. All right, anyway, on that morbid note, questions on this? I was watching his back now. All right, be nice to her. All right, page 129, numbers 14, 16, 18. Page 129, numbers 14, 16, 18, doing the same kind of thing where you're determining yes or no, are these values possible solutions? If they are, circle them. If they're not, cross them out. Just cross out the no good solutions, circle the valid solutions. 14, 16, 18. Very quickly at your seats. Let's go ahead and take a look at our answers together here. Number 14, which ones are good to go? Brecken. Good, -1 and 0. Number 16, Noah, which ones are good to go?
-5.
Just the -5. Number 18, Maddie? -4 and -2. Questions on those. All right, turn the page. Excuse me, look back, look up. I can't read my own notes. Look up at the top of page 129, it says right there. Look at table B. Some key words in algebraic translation. Now, got a little bit of an issue here with the way they printed this. Because when you see less than, it means to subtract. This symbol does not mean less than. It means is less than. So what I need you to do is before every one of these little phrases, put the word is. When do I know to use a less than symbol? When it says is less than, is fewer than, is under, is below. Normally is means equals, but when it says is fewer than, less than, is under, is below, is less than, that tells me to use this symbol. However, I would use the less than or equal to symbol if the expression says is at most, or is no more than. For instance, we talked yesterday about Maddie and buying the dress, and she had $38 in her purse, and she's like, that's the most expensive thing I can buy. I can spend at most $38. Now, if she finds an absolutely gorgeous dress on the clearance rack for $5, I don't know if they make them that cheap. I don't know. I should buy my wife more dresses. But anyway, it's safer to let her buy her own. Anyway, I get myself in trouble with that. Anyway, but if she finds an absolutely gorgeous dress for $5, would she buy it? Well, of course. It's not like she's hell bent. She has to spend all $38. She's willing to spend less, I'm sure, right? You're not one of those like, no, if I don't spend at least $30, I wouldn't buy it. You're not one of those, are you? Okay. You're like, yeah, $5, sign me up. As long as it looks nice. You know, it's like a burlap sack, you know. Yes, but it's only $5, you know. Anyway, yeah, is at most $38. Is no more than. Do we see how that means less than or equal to? What about greater than or equal to? Well, if it says is at least or is no less than. For instance, maybe Noah, he's mowing lawns, trying to make money, working with his hands and working hard with the sweat of his brow, as the Bible talks about, being a biblical man. And he's mowing lawns, and there's this yard, and these people are saying, hey, we'll pay you $15. He's like, no. I need at least 20 to make it worth my time. What if somebody wanted to pay you 30? Would you take it? Of course you would. You just want at least 20. 20 is your minimum, and then anything above that, absolutely sign me up, right? Okay? Is at least greater than or equal to. Is no less than greater than or equal to. But what about just plain greater than? Well, if it says is more than, is over, is above, right? Do we understand how these key words come together? Again, the key part is is. Is normally means equals, but if it's followed with one of these phrases of comparison, it doesn't mean equals anymore. It means one of these other symbols. I suppose this would be true. What if it says is not? That's not on the chart. What if it said is not? Well, is means equals, so is not would mean not equals. Make sense? All right, so anyway, take a look at the example problems. Example 4.1f. Read letter A for us, if you would, Maddie. Well, you know the sum of a number and 3 means x plus 3. And if it said is 7, you would say equals 7. But it says is at least 7. So could it be bigger? Yeah. Could it be 7? Yeah. It just couldn't be smaller, right? At least 7. So greater than or equal to 7. Read letter B, Noah.
The number of cars at the dealership is fewer than 75.
Here, the number of cars, well, that would be x. And it doesn't make anything else. It just says is fewer than 75. So x is less than 75. Not less than or equal to, just is less than 75. Make sense? Look at letter C. Read that one for us, Brecken.
2 less than 3 times the number is no more than 13.
Well, again, you know 2 less than, that means something minus 2. Notice it didn't say is less than, okay? 2 less than, something minus 2, 3 times the number, okay, that's 3x. So 3x minus 2 is, normally means equals, but is no more than. Well, could it be 13? Sure, that wouldn't be more than 13. So it could equal, or it could be less than or equal to 13. Questions on letter C. And they finally, by the way, get around to that little note there about the difference between 2 less than and 2 is less than. The is has to be present. So again, why they didn't put that in table B, I have no idea. But, you know, they didn't consult me in writing the book. Questions on that? All right, turn the page, page 130. Look at number 20. I want you to just algebraically represent, forget the question they ask, just algebraically represent twice the number added to 6 is less than 23. So just represent the statement. We'll address the question in a moment. Twice the number added to 6 is less than 23. All right, check your answer. Twice a number means 2x. Added to 6 means plus 6 or 6 plus 2x. Either way, addition is commutative. Is less than. What symbol should I put? The less than symbol, right? Is less than 23. Do we have this written correctly? Could 10 be a solution? Do it in your head very quickly, class. No, that'd be 26. 26 isn't less than 23. So no, 10 is not a solution. Look across at number 21. Write this. The sum of two consecutive integers is greater than 50. The sum of two consecutive integers is greater than 50. How do we represent consecutive integers again, Noah?
X and X plus 1.
And so it says the sum of consecutive integers, x plus 1, or 2x plus 1 you might have had as well, is greater than. So class, we need to put a greater than symbol, 50. How many either had this or 2x plus 1 is greater than 50? All right? And then could 25 be one of the numbers? Well, if it was your second number, what would be your first number? Or what comes before 25? 24, right? If 25 is the second number, the first number would be 24. Is that sum greater than 50? But what if 25 is the first number? What's the next number? 25 is the first number. What's the next number? 26. Would that sum be greater than 50? So 25 could be one of the numbers. It would just have to be the first one. Look at number 27. Drop all the way down to number 27. The square of x is greater than or equal to 10. This one should be pretty easy because they came right out and just said it. All right. When I write the square of x, class, in other words, I just write x squared, is greater than or equal to, well, obviously that's the greater than or equal to symbol, 10. Do we have this? Could 3 be a solution? No, because 3 squared is 9. 9 is not greater than or equal to 10. Look at number 28. The fourth power of y is less than 20. The fourth power of y is less than 20. What do I write, Noah? Don't overthink this. Yeah, it is less than 20, less than symbol 20. Could 2 be a solution? What is 2 to the fourth power? 16. Is 16 less than 20? Yeah, so 2 would be a solution there. Look at number 31. The sum of a number and 4 is less than 7. How would we write that? The sum of a number and 4 is less than 7. Brecken, when you've got it. Yeah, x plus 4 is less than 7. Is 5 a possible solution, class? No, that'd be 9. 9's not less. How about number 32? The sum of a and b is less than the product of a and b. Maddie? Yeah, and then it says, could a equal 2 and b equal 3? Yeah, because what's 2 plus 3? But 2 times 3, 6, and 5 is less than 6. Questions on these? You're going to practice with some of these for homework this evening. For homework, pages 129 to 130. For homework, pages 129 to 130. 129 to 130, do numbers 15, 17, 19, 22, 29, 30. And then back on page 91, do word problem 61. Back on page 91, do word problem 61. Again, pages 129 to 130, 15, 17, 19, 22, 29, 30. And on page 91, do word problem 61. Take a look at that tomorrow. Have a wonderful rest of your day.